Code can be generated at blinding speed today. With AI agents assisting, hundreds of lines populate the screen in seconds, making a project feel like it's finished before it really even begins. But raw code is fragile. Without a clear architecture, that speed quickly creates a vacuum. Folders become disorganized, error handling is left ambiguous, and when another developer tries to step in, they face a wall of missing context. Look at this list of symptoms from our internal process documentation. A weak project foundation is obvious when the repo only contains a folder structure, testing is completely ignored, and the deployment strategy is missing. The code exists, but the project itself is unworkable. To solve this, we use a project blueprint. It acts as the standard starting structure for every new build, giving developers and AI agents a set of instructions to plan, build, and review their work consistently. To get code to the actual finish line, we move it through a sequence of documentation, testing, and deployment gates defined in the blueprint. The life cycle of a reliable feature begins far away from the code editor. Forcing absolute clarity up front prevents the need for massive rewrites down the line. In the project intent section of the blueprint, developers define the problem being solved, target users, and long-term direction. Moving down to requirement documentation, the blueprint establishes boundaries, mapping out everything from user experience to data structures and acceptance criteria. By checking these boxes early, the blueprint acts as a protective barrier. It locks abstract ideas into a tangible framework, protecting the final product from scope creep and unguided features. Once the requirements are locked, the build phase begins. This is where architectural paths and code structures are established. This section, decision documentation, provides a historical record. Here, engineers record exactly why a certain tech stack or database design was chosen, eliminating guesswork so a developer joining next year understands the rationale behind every technical shortcut. Next, the environment and code structures are defined. Establishing clear dependencies, precise folder responsibilities, and local setup steps ensure the application is reproducible and never relies on just one person's memory to run. This structure is vital because of a modern paradox. AI can write functions endlessly, but that high-speed output requires strict human constraints to remain accurate. Here in the Agent Usage Guidance section, we provide those constraints. By feeding AI tools our architecture rules, coding standards, and known limitations, we prevent the model from drifting off target or inventing new processes. During implementation, the blueprint acts as the shared source of context for the entire team, aligning the output of human engineers and machine contributors under one standard. Even when the logic is written, the code enters a final validation phase, where it's checked against the project's initial quality standards. This blueprint section covers testing and QA. Testing is a core requirement from the start, not a last-minute patch. Right below that, we establish logging and error handling, separating developer details from user-facing messages, so the software remains observable in production. Finally, we reach deployment and release. By writing out the environment configurations, migration steps, and rollback notes ahead of time, deployment transforms from an unpredictable event into a routine. A feature is ready for release when its entire lifecycle is observable, tested, and structurally sound. Once the software is live, the work shifts. A live feature immediately enters a cycle of maintenance and iterative improvement. Looking at the maintenance and improvement section, we track ongoing realities like technical debt, known limitations, and process lessons. The document continues to function as a guide for future builds. We know this foundational work has succeeded when new developers understand the codebase immediately. Coding agents produce aligned output, and the project continues seamlessly even if a key team member leaves. This framework scales with the complexity of the build. An internal tool requires less depth than a client-facing platform, allowing the documentation to evolve alongside the team's needs. Software engineering is the construction of an environment where code is documented, tested, and observable. When a project reaches that level of structural integrity, it finally meets the standard of done.